Dear student, today we are going to start corrosion control. So far we have discussed corrosion starting from introduction to effect of various factors including implications, types, mechanism of action and different examples. And to start with corrosion control, I would like to tell one thing. Anything which is spontaneous will go of its own, and any spontaneous process is spontaneous because it leads to higher stability, and therefore any natural process which is spontaneous cannot be controlled absolutely. Similarly, corrosion is actually oxidation, and oxidation is a spontaneous process because during oxidation energy is lost, energy content will be reduced, and therefore stability will be increased. As all of us know that the relation between stability and energy, they are inversely proportional. Therefore, corrosion being a spontaneous process, its absolute control is never possible. The only thing we can do, we can try to reduce the intensity of corrosion. It means if we do not take any action, if any metallic article or a metallic structure goes for 1 year with proper precautions, it will go for 5 years, 10 years. This kind of longevity can be provided. And to do that, we have many options. And options are: number 1, design; number 2, using pure metal; number 3, using metal alloy; number 4, cathodic protection; number 5, modifying environment; number 6, using inhibitors; and number 7 is coating. I repeat, we have in general 7 different options. Number 1 is design, number 2 using pure metal, number 3 using metal alloy, followed by cathodic protection, modifying environment, using inhibitors and coating. And if we want to have maximum protection against corrosion, we have to adopt all these in combination, many of them in combination or individually. And if we choose for individual protection, suppose we have not actually monitored first to 6, we have made a structure without any planning, and without coating, if it actually goes for 6 months, if we provide coating, it may go up to 2 years, 3 years like that. And therefore I am telling you, if maximum protection against corrosion is desired, so we have to take care of all these issues. Today we will be talking on design. There are many points in design, and we will discuss one by one. Design. Many of us know that if we go back by 20 years, 25 years, 30 years, whenever we desire to make any kind of building, house, this kind of thing, we never go for planning but design. Nowadays, multi-story buildings are being made, and without planning and design it will not be passed, and therefore planning and design has become a compulsory affair. But in earlier days planning and design was not there, and therefore, and this is predominant in India and in particularly Asian countries like Bangladesh, Pakistan, Maldives, Sri Lanka, Bhutan, Nepal, this kind of states. We go generally without any planning and design, and because of that, right from the beginning, we inculcate a favorable condition for corrosion to. If we make a structure, metallic structure, without any planning and design, and if we wish it to go for 20, 30, 40 years, it will never be fulfilled. A very simple example we can mention here. The buildings made by British Empire hundreds of years ago, these buildings are even today standing tall. But building made by the modern India is breaking down surprisingly because of many reasons. And most importantly, proper design is not there, and therefore in corrosion also proper designing is the paramount importance, and without proper design we cannot think of the metallic article to go for a longer period of time. Few things we should keep in our mind. Corrosion being a natural phenomenon, it will be there, it cannot be controlled, but we have to ensure that corrosion, even if it occurs, should not be localized, because in our earlier lectures we have seen in localized type of corrosion, anodic area is very small, and resulting in the larger cathodic area, demand of electron will be very, very high, and this can be fulfilled by the small anode by undergoing rapid oxidation, resulting high rate of corrosion. And therefore we have to ensure that corrosion, even if it is there, it should not be localized. And the most and foremost condition for any design is that the design must have minimum possible stress. Stress is mainly created by bends, joints, and therefore we have to keep in our mind while designing that the design must possess minimum as possible number of joints, bends, bending area, so that it will have minimum stress, strain. In this context, I would like to give you one example. Suppose I have told you I have 10 milliliter of corrosive liquid and I want to keep it in a container. Suppose I have told you, please make a design of a container in which I would like to keep this corrosive liquid. Now these are the different designs you have proposed. Suppose this is one design, this is another design, this is another design, this is another one, this is another one, 1, 2, 3, 4, 5, 6. And if you are asked which design we are going to select, before selecting you have to consider so many parameters, so many aspects. I have told only 10 milliliter of corrosive liquid is there, and therefore in that situation, you know, there will be stress, joint, there will be stress, because joints are there, here there will be stress, and therefore if you carefully observe, minimum stress will be in design number 6. And therefore, initially, depending on the volume of corrosive liquid we are talking about, we should go for design number 6. But in case, if I tell you, I want to keep 10,000 liters of corrosive liquid, in that situation, we will not choose 6, because if we go with this structure, the size of the container will be as large as it is from here to New Delhi, which is not acceptable by the industries. And therefore, whenever we are talking about design, we have to consider so many aspects. But the basic principle in designing, in every design, is that number 1, it must have minimum possible stress, that is minimum number of bends and joints. Number 1. Number 2, whenever we are making any design, we have to plan in such a way, we have to think in such a way that there should be possibility of using single metal to make the structure. Because if we are able to make single metal, the possibility of making electrochemical cell will be nullified, and therefore this kind of corrosion can be easily controlled. Suppose this is not possible, because the person came to us for this design, has told us that you have to make a design where 2 metals are to be used. In that situation, what we will do? We have to ensure a design, we have to propose a design in such a way that both the metals will be used, but we will definitely try to avoid their contact. And if we can do that, the electrochemical cell will not be produced. Number 4, suppose a situation is like that, where 2 metals are to be used and they must be in contact. In that situation, what we will do? What we will do? In that situation, we will have to have a design where 2 dissimilar metals being used in such a way that there must be larger anodic area and smaller cathodic area. As we know that if cathodic area is small, where demand of electron will come, the supply of electron by the anode will be minimum, and therefore rate of corrosion will be minimum. So in that situation, we have to ensure that design should be such that metal being used should provide larger anodic area and smaller cathodic area. Another situation may be there. Suppose the situation is like that, we have to use 2 different type of metal, they will be in contact, and they are not giving you larger anodic area. These are the conditions. In that situation, what we do? Then in that situation, we will propose a design in such a way where we will choose 2 different metals holding very close position in the electrochemical series, so that the difference of their electronegativity or electrode potential will be minimum, and intensity of electrochemical cell being produced will be minimum. So for today, we have discussed only 5 different principles. There are many other principles which we will be discussing in our next lecture. I would like to request you to go through the video very carefully. If there is any doubt, get it noted, which is being discussed and solved in our next lecture. Thank you.